Hi students, in today's video we are going to be checking the type and structure of variables. We are also going to be looking at how to do a summary statistical analysis of the variables and to check the levels of categorical variables. Now it is important, coming to the first one, which is checking the type and structure of column variables or column names. Now, it is important to ensure, and a rather tedious activity to ensure, that all the columns in your data set have the correct data type. Now, this is sometimes automatic, but sometimes when you import in data sets from the internet, they may not be encoded correctly. So, for example, you may observe that a numeric data type has actually been encoded as an object and therefore needs to be converted back to numeric. And similarly, you might find that there is a Boolean variable which is 10, and this is encoded as an integer data type, whereas it should actually be an object. Since it is categorical in nature. Leaving it as an integer data type will cause a lot of problems for analysis. Alright, now how do we go about changing the correct data types? So first let's look at the first thing we can look at is the first step in checking the data in a data frame is to use the dot shape attribute. This is an attribute of a data frame and hence does not have those round brackets. This gives us the exact number of rows and columns in the data set. The next thing to do is to check the data types using d.d types. This is again an attribute. Now this shows us that there are a rather large number of objects in this data set. This is the Bollywood data set, and obviously you would expect things like movie release and genre and movie content and lead actor, etc. to be an object variable. There are some float and integer variables such as budget, profit. These are all, as you can see, either float or integer. However, there are some variables which are not necessarily correctly encoded. So we may need to align them. For example, we may find that item song yes no has often been encoded incorrectly as integer, whereas it should be encoded as string. So how we need to therefore then convert it to a string using the dot as type method. So how do we do it? df1, the name of the column, and just copy it exactly as it should be. df1 dot as type string, and you pass in string into the dot as type function method. This should convert it to an object, and similarly we observed that success failure was also encoded as an object, as an integer, when it should actually be an object, so we convert this also. Now that we run d types, we should see them converted. However, sometimes note it may not reflect, like for example over here, it is still reflecting as integer. This don't be too concerned about it. This is a known Pandas issue. At the back end, however, these will have been converted, and I will show you how I know that. Now, if you wish to convert a large number of variables and change their data types, you can also use the you can pass in a dictionary of key value pairs of the column and the data type into the dot as type function. The syntax here is df1, that is the entire data frame, df1 dot as type, and then you pass in the key value pairs. There's YouTube views. We are converting this from float to integer. YouTube likes is being made into float, and YouTube dislikes is being made into integer. Let's run it and then run df1.d types, and we can see that YouTube views is indeed integer, this is float, and this is integer. Alright, now let's look at the statistical analysis that we can, a preliminary statistical analysis of the numerical variables. This is done by what is known as the dot describe method. Okay, This is a very powerful method and a very simple method which gives you a descriptive analysis of all the numerical variables. Now observe over here that we do not have the variables item song, yes, no and success, failure, which indicates that Pandas has actually converted them into object variables, even though their type was reflecting a little incorrectly as as integers. Now over here, for each of these numeric variables, we can get the count, the mean, the standard deviation, the minimum value and the maximum value, as well as the percentiles, 25, 50 and 75 percentile. This is very useful for being able to identify any major outliers. If something is looking very off, for example, in this column, we can compare it to the mean. The mean is 56 and this is 75. So we can see that there is a fairly major outlier which is existing over here. And you can also compare this to the median, and the median value is 27.5, and then again your maximum is 735. So this is clearly an outlier. This is just a preliminary analysis, but we can already start flagging outliers. Another thing which we can do is we can then look at each column of the object columns and find out what are their levels and frequency distribution across the levels. Now let's look at the genre defined column. We use the dot value underscore counts method, and as you can see in this, it gives you a list of all the genres which are encoded in this genre method. So you have drama, comedy, sci-fi, etc., and it gives you the frequency counts. Similarly, you can look at the item song yes, no dot value underscore counts. This again, this is the variable which we had actually converted to object, and as you can see, you have 0 which has a frequency of 88 and 1 which has a frequency of 58. So again, this gives you an idea of the levels. I'll stop here for this video, and in the next video I will be taking up column operations in Pandas.